take them downing, take them downing, take them down. As you look, the whole room explodes. Take them downing, take them downing, take them. As you look, the whole room explodes.
Okay, right. So let's start with who I am. My name is Martin. I studied mathematics a long time ago, investing algebraic structures with a computer. So if you imagine me playing with Rubik's Cube and having a lot of fun, that's very close to it. Since then, I've done IT in many roles as programmer, project manager, responsible for a computing center, and on and on and on. These days, I'm primarily an architect, both in the role consulting other companies, how their architecture should look like, and also for our own product, the ArangoDB database. Though today, I'm not going to talk too much about ArangoDB database. I'm going to talk about the match between domain-driven design and non-relational databases. And to set the stage, let's imagine a project, yet another web shop. And I guess we've all been there, and so that should be familiar to you. It starts off well enough with a specification workshop where the product managers just talk about what they expect from this web shop. So they tell the developers that they want the users to be able to browse through the web shop, selecting the stuff that they want. Of course, there needs to be a search, and the good products needs to be on top of the result list. And all this talk is rather informal. But all the participants are in very high spirits, and there is no disagreement, probably because all the issues where there might be conflict are not even talked about. Which, by the way, is not true for this video if you haven't seen it. It's a very funny video. And so after the specification workshop, the developers go on and they develop, and they do it with all the right buzzwords and all the right technologies. So with object-oriented and three-tier architecture, model view controller, and responsive design, and what you have everything is very well, everything is very good. Except when there is the handover of the product, suddenly the business side is all not very positive. They are telling the developers that there are certain features completely missing, so there are no recommendations in this web shop, and there should have been, that certain parts are not usable, the checkout, for example, and stuff, and sentences that fall are, but that's obvious, and stuff like that. They're also claiming that certain parts are just not, are there, but basically done the wrong way. So yes, certain products show up on the top of the list, of the result list after a search, but this is based on what maybe on user ratings and not on the net margin or stuff that the business cares about. And finally, the business side sums it up by saying the developers are incompetent. Well, what the developers think of the business side is not at all much better. They think that it's all the business side's fault because they didn't specify correctly what they wanted to have. So there are those two sides, and the two sides blame each other. Okay, let's have a show of hands. Who has been in such a project and suffered through it? I certainly have, more than one time. Okay, some of you have too. But in fact, it is not because the business side are morons or the developers are just stupid. It's a systematic problem. And it's a systematic problem that has to do with language. And it's been with us for a very long time. Even the Bible talks about it, talking about the Tower of Babel. And so I'd like to talk about two parts of that. One is the functionality is not gathered in a methodical way, and the result of that is that obvious functions are missing. The business side is not talking about the obvious functions because they think it's obvious. And as a result, the obvious functions are never talked about and they are never implemented because what is obvious to the business side is not obvious to the developers. The second part is there is no common language. Yes, there was the talk of putting the good products on the top of the search result list, but there was no common understanding what that good meant. And so if there is no common language, then there is misunderstanding about the details, how this functions should work and what should happen. So how do we tackle those problems? Well, one way to tackle is with agile development. And agile development helps to gather the functionality in a methodical way through several steps, which I'm not going into detail right now. But there's stuff like the continuous interaction between the developers or the Scrum team and the business side, maybe represented by the product owner, depending on which flavor of agile development we're talking about. There's stuff like the product backlog, stories and epics, which help to really drill down into the functionality and so on. And by the way, I don't know whether you can read it, but this is the pointy-haired boss introducing agile programming with his usual show of competence in this company. So, sorry, I'm not going to talk about agile development today either. You've probably heard talks about that, you've probably read books about that, and there are many places where you can find information about that. I'm going to talk about the other problem, about the language problem. And there has been a book or an approach called domain-driven design that tackles this language problem. Domain-driven design was described by Eric Evans. He himself doesn't want you to say that he invented it because he said it's just a collection of ideas that was floating around. So he described it. He described it in his seminal book, Domain-Driven Design. Design-Driven Domains, that might be another interesting book. Domain-Driven Designs, and as I said, it's an approach to model a complex business-oriented software. So there is a scope. It's not a model, an approach to model something like Photoshop or something. But if you have a business-oriented software like a web shop or so, it's an approach to model that. It centers around the business logic, and the way it does that is you model the application domain and use that to really talk about the requirements and the stuff that you want. And that's where this approach gets its name, from the domain, and the domain drives then the design. And there are several parts of it, but the part I'm going to focus on today is the language. And there is a language that's pervasive, that's ubiquitous, that's used throughout the project. It's a common language, and the common language is used by all the participants. So it's used by the domain expert, the analysts, the developers, the testers, the business and product representatives, and what on. And it's also used during all phases of the software project. So it's used while you elaborate what it should be, while you gather the requirements, when you write, say you're doing test-driven design, you're describing the tests and implementing the tests, and so on and on and on. So in all phases of the project. Now, such a common language, a ubiquitous language, must be based on the business logic, because the implementation is, well, an implementation detail. But the business logic is really fundamental to what you're trying to achieve. So it's based on that. And there are certain parts to that, certain, let's say, elementary parts in the domain-driven design that center around modeling what are we actually dealing with. And the stuff that you have there, there are several different aspects of objects or kinds of objects. One kind of objects are the so-called entities. Entities are things that do have an identity, and two such, sorry, that's a misprint. It should be two entities are different, even if they have the same values for all the attributes. An example of an entity would be a person. Sorry. Another example of an entity would be a shopping cart. Two empty shopping carts are still two different entities, because if you put something into one shopping cart, the other shopping cart stays empty. And that tells you that those are really two different objects, two separate objects. And the example I just gave you shows that the immutability is really one of the key aspects that requires you to think about identity for such entities. The picture, by the way, is from a science fiction movie called The Sixth Day, with Arnold Schwarzenegger meeting a clone of himself. So if you think a movie with one Arnold Schwarzenegger is bad, a movie with two Arnold Schwarzeneggers is, yes. On the other hand, something that you have are the so-called value objects. They have no identity. They are only defined by their attributes. And because they are only defined by their attributes, they have no identity, you can copy them at will. You can make a copy, or you can collect them together what you want. Because I gave you the example, mutability usually requires that you have entities. So if you have value objects, they must be immutable, at least from a business point of view. Of course, internally they might change, but as far as their business, the attributes that describes them in terms of the business, they must be immutable. An example of such a value object might be a product description. You can copy the product description around at will, and it's still a valid product description. The picture in that case, by the way, is Heidi Klum, a German top model who hosts the show Germany's Next Top Model. She has no recognizable identity, is only defined by her attributes, and as you can see from the picture from Madame Tussauds, she can be copied, and the copy is just as good as the original. And as far as I can tell, she has not changed visibly in the last 20 years. So. The third type of objects that you have are the so-called aggregates. An aggregate is a collection of entities and value objects into one transactional unit. So on the right-hand side, I have an example of that. And the blue the blue frame is the aggregate. And the orange things are basically entities in that. And then the green things are supposed to be a value objects in that. So you have one aggregate, you have in that aggregate a entity for the session, an entity for the user with his name and password hash, an entity for the shopping cart, and another one for the wish list. And the things in the shopping cart are then value objects. Yes. There must be one entity, in this case it's the session, that is basically the defines the access to the whole aggregate and points basically to the other objects that make up the aggregate, and it controls how you can access the other objects, and it also thereby controls that certain invariants are being upheld. For example, in this case, that say if something is moved into the shopping cart, it's at the same time removed from the wish list or whatever. Then there are the next type of things that you have in domain-driven design are the so-called associations, and those are the relations that you have between entities and maybe value objects. Most often they are between entities, but they can be between value objects too. They have properties, and they are usually immutable, though that is not required. Here we have the relations between, say, users, and the associations are who knows whom or who shares a flat with who, and so on and on. Finally, there are factories that are things that create other things. If you're and you should have read about programming patterns or development patterns, software patterns, then you know those things. They correspond directly to those patterns, the factory, the builder, and the prototype. An example here would be a factory that creates such an aggregate consisting of a new user with his wish list and his shopping cart. Of course, for a new user, the wish list and the shopping cart are probably empty at the start. And finally, there are repositories which do store entities and aggregates. They are the abstraction in domain-driven design of persistence, so they correspond to the bottom layer in the three-tier architecture. They have methods for searching the entities or the aggregates therein, and so on. You can, and in some cases may want to store value objects in repositories, but because value objects can be copied around freely, are immutable, it does not make that much sense, at least on an abstract theoretical point of view. An example of that could be, for example, the product catalog, where all the product descriptions and information about those and availability of those are stored. Okay, with that, we have now basically let's say, the vocabulary of the language of that common language. And so now everybody can talk in the same language. Everybody? Unfortunately not. And that's when we have to turn to relational databases. If we turn to relational databases, suddenly very different terms pop up. You have so-called relations, which are not what you probably think. They are not a relation between you and your girl, boyfriend, or significant other, whatever. They are also not the relation that you have between one data set and another data set through a foreign key. That's often a misconception that this is a relation in a relational database. It is not. In a relational database is a subset of the tuple space, and there are certain operations on that. And you can define those operations in a very mathematical fashion, and if you do that, then you get a relational algebra. And the guy who says this is called Cott. Thank you very much. It's called Cott, and he invented that, and he's very famous for it. You suddenly have normal forms, and there is a poster defining ways how you normalize your data. It's by Mark Rettig, and it's very useful. Nobody really knows, I think, how many normal forms there are, and you can always come up with new ones. But what are normal forms really? What they mean is if you have your object, your shopping cart or wherever, then you have to take it apart and distribute the pieces all over many tables in your database just to store that object, which looks nice here, but it's not so nice to put it together again. And how do you put it together again? Well, you need instructions for that or joins to put those things together again. This is a instruction how to build IKEA-like a TARDIS that is a time machine. Wonderful thing. I especially like the fact that you need infinitely many wooden pegs to put that thing together. You also need transactions, which are basically rules. Oh, sorry about that. Yes, there are sometimes joins that you need for other purposes, but I bet that for something like a web shop, most of the joins executed on the relational database are there just to put objects together again that were stored and distributed over many tables. I'm willing to bet on that. You also need transactions, and transactions basically are a way to make certain that nothing gets lost when you distribute the objects or put them back again. And likewise, there are transactions for other purposes, but most of them will be that. What that is, in short, is database developers speak their own language. They don't speak in the terms that I defined earlier, aggregates and value objects and the business logic. They speak in tables and relations and joins and stuff like that. And they speak in entity relationship models and so on. And no business user ever understood really what that meant. So that is a group of developers that speaks their own language. Aha. Non-relational databases, no SQL databases. That's where they come in. I can probably flip through that. There has been a development of non-relational databases in the recent past. That's because the conditions have changed. We have different functional requirements from what was required from a database 30 years ago, different non-functional requirements in terms of volume, variety, and velocity. The hardware, what used to be terribly expensive, is now suddenly very, very cheap, and all that changed and has led to basically a big bang. As a result of that big bang, there are many, many non-relational databases. They're usually classified in 4 categories: the key value stores, and for each category I've just given some examples, so if your favorite database is not there, please don't, it's not representative. It's a key value store, the document databases, extended column stores, and graph databases. And now I have to make a plug. Recently, there are the so-called multimodal databases, which basically try to be all of those things and aggregate that. And ArangoDB, the database for which I'm the architect, is one of those. There, I've said it, and we're all good. Key value stores are the simplest. They just map a key to a value, and I just flip through that. Document databases then start to store the documents as a set of attribute value pairs. They can be structured, so you can have in such a document a list of things, and each thing can then again be a sub-object and so on. You usually group those documents into so-called collections, which, if you want, correspond to the tables in a relational database. The external representation, as in this case, is usually JSON, and an example would be a product catalog. Graph databases, we heard about graph databases before the break. They have edges and they have vertices, and you can, for example, use them to model the relation between, remember we're talking about a web shop, so you can use them to model the relation between various products. One product is the successor of another product, or one product is an accessory to another product, and so on. Okay. So finally, how do they match? So that should say 5 minutes. It does. Perfect. How do they match? How is the match between domain-driven design and non-relational databases? And what I'm going to show you, and what I say up front, is it's very good. It's very, very good fit very good match. So let's play this through. If we talk about entities, then an entity, of course, maps directly to a document in the document database. If you look into more detail what an entity is in domain-driven design, you see exactly the same. And the identity you have there is every document has its identity that may be through an ID or through a key attribute that depends on what you want it to be. You have complex structure in your domain-driven design for the entity while you map that to the structured attributes I talked about earlier. You have the variance that you have, and domain-driven design talks about the variance both on the time scale and between various objects. And that is no problem because you have a schemaless document database, and that different documents in your database can have different number and types of attributes is no problem. And so what you don't need is an entity attribute value structure that you would need if you would try to map it to a relational database. Value objects, they can be a document in their own right, but what they also can be is a sub-object that just exists in another object, which in turn may be an entity or a value object, and they can be embedded basically within that other object, so that's perfect. The immutability of the value object, that must be implemented on the application level. The database does not guarantee you this. You have to make certain that it is. If you talk about aggregates, then that maps very well again. The aggregate maps to a document, and the document then holds direct references to the other documents that make up the aggregate. And the various document databases have various different mechanisms for those references, but they all work fine for domain-driven design. I said important for the aggregate is that you have a central access, and that again must be implemented on the application layer, making sure that you access your aggregate always through your, say, top level or root entity, which was in our example earlier on the session document, sorry. The associations, well, they map well too, but not for a document database, but for a graph database. The associations correspond directly to the edges that you have between two documents. And that such an association can have a type, matches to the type attribute or the label that you might have. And the additional properties that you can have here map to the additional attributes that you can have to your edge in the label. And the access methods that actually are talked about in the book correspond to the graph algorithms. So for example, to implement something like recommendations for our web shop, you can use a path search. Repositories map then to collections in a NoSQL database. That is the place where you store those entities or those documents. And storing in a repository then is a query in such a collection. And of course, what you want to have is that this query is fast by using an appropriate index. So I hope flying through that, I could convince you that there is a very close match, certainly much closer than the concepts that you have in relational databases. To sum it up, a common language helps you really have your business side talk to your developers and avoiding those misunderstandings of what does good mean or something like that. Domain-driven design through this book, is an approach that both demands such a language, but also supports it through the appropriate tools and methods and approaches. The development with relational databases does not fit very well with that because it requires its very, very own language and corresponding to the language, a way of thinking about stuff. The non-relational databases that exist are modern databases that are very, very powerful. And there is a direct match between the concepts in domain-driven design and the concepts and the objects that you have in NoSQL database. And for that match to be 100% perfect, what you need is a multi-model database that at the same time gives you the documents and the graph approach for the associations. And with that, I'd like to thank you for your patience, and thank you.
Thank you very much, Martin. It was very interesting. Are there any questions? We have time for one. Anybody? Okay. Thank you very much.
Thank you.